Class 11, Chapter 1, Miscellaneous Exercise, question number 4. Show that the following 4 conditions are equivalent. I have to show that these 4 conditions are equivalent. So what I will do, I will show that 1 is equivalent to 2. That is, suppose if I will show that x is equal to 5. Suppose this is 5 and this is x. If I will show x is equal to 5, it means this x is also equal to 5, and then if I will show that first is equivalent to 3, it means this will also be equal to 5, and first is equal to 4, it means this is equal to also 5. So all will be equal in this way. So what we will do, we will just divide it into 3 parts. Part 1, I will show that first is equivalent to 2. In part 2, first is equivalent to 3. In part 3, first is equivalent to 4. So let us start with first part, in which I have to show that first is equivalent to 2. That is, I have to show that A contained in B if and only if, or I can say equivalent to A minus B is equal to 5. What do we mean by equivalent to? In that case, if I will start from here, I should get this, and if I will start from here, I should get this. This is the meaning of equivalent. So what I will do, I will start from this statement and I should prove that A minus B is equal to 5. So let us start from here. So this also can, I have divided into 2 parts, 2 cases, case 1, case 2. First one, if I will start from here, I should reach here, and if I will start from here, I should reach here. Then only I can say that the both statements are equivalent. Reach here means if I will start from A contained in B, then I will get A minus B is equal to 5. And if I will start from A minus B is equal to 5, I should get A contained in B. Likewise, we will be doing in part 2 and part 3 as well. Now, in this part, we have case 1. Case 1 is I will start from here and I will get this. I have started from here, A contained in B. Now, what I have to show? I have to show that A minus B is equal to 5. Now, if possible, suppose A minus B is not equal to 5. This part can be proved with the help of the contradiction like this. If possible, suppose A minus B is not equal to 5. So, it means x belongs to A implies x doesn't belong to B. Why? Because suppose this is A and this is B. If A minus B is not equal to 5, it means there is some element in A which is not there in B. Then only their subtraction or their difference is not equal to 5. So it means x belongs to A implies x doesn't belong to B, which is a contradiction. Why it is a contradiction? Because A is completely containing in B. So there is no element which belongs to A but doesn't belong to B, because A is completely there in B. So it means whatever we have assumed that was wrong. It means A minus B is equal to 5. So we started from here and we reach here. Now in case 2, we will start from here. A minus B is equal to 5 and I have to show that A contained in B. Now A minus B is equal to 5 and I have to show A contained in B. A minus B is equal to 5 means suppose A is 2, 3, 4 and B is 1, 2, 3, 4, 5, 6. Now A minus B is 5. It means all the elements of A are there in B. Only then A minus B is equal to 5. So all the elements of A are there in B. Then only A minus B is equal to 5. What does it mean? What you can observe from here, if A is completely contained in B, then only their difference is 5. So it means A contained in B. Now part 2, in part 2 we have to show that first is equivalent to 3. Now to show first is equivalent to 3, I have to consider the left hand side and prove it to reach till right hand side, and I have to, in case 2, I have to start from right hand side and reach till left hand side like this, left, right. Now I will start from here. In case 1, A contained in B. What I have to show? I have to show that A union B is equal to B. Now to show A union B is equal to B. Now to show in question number 3, previous video also, we have shown that 2 sets are equal. When 2 sets are equal? When one is contained in other. So these 2 sets, if this contain in this and this contain in this, then I can say that both the sets are equal. So this is already true. B is definitely contained in A union B, because in A union B both are there. A is also there and B is also there. So we know that B contained in A union B. Now what I have to show? I have to show that A union B is contained in B. Now to show some set, one set is contained in other set, what we will do? We will consider an arbitrary element belong to A union B, and we will show that it belongs to the other set also, to B also. Then A union B is contained in B. So let us see how we have shown this. Now x belongs to A union B. What does it mean? X belongs to A or x belongs to B. So in this case, so it is done. X belongs to B. Now if it is x belongs to A, it will definitely belongs to B as well, because we have considered A contain in B. So if A contain in B, if x belongs to A, then x belongs to B as well. So in both the cases, x belongs to B we are getting. So it means A union B is contained in B. So by 1 and 2, left hand side contain in right hand side contain in left hand side. So it means both the sets are equal. So it means we get A union B is equal to B. Case 1 done. Now in case 2, we have to consider the vice versa part, that is A union B is equal to B to show A contain in B. So in that case also, I have to show that one set is contained in other set. I will consider an arbitrary element belongs to this set, and I will show that this belongs to B as well. So I have started with x belongs to A. Now if x belongs to A, x belongs to A union B as well, because in union we have all the elements from A as well as from B. So x belongs to A implies x belongs to A union B. Now A union B is equal to B. So it means x belongs to B. It means A contain in B. So we started from A and we reached x belongs to A implies x belongs to B. It means A contain in B. So done. Case 2 as well. Now in part 3 also we will be doing with 2 cases. Now part 3 is, I have to show that first is equivalent to 4. Now first is A contain in B and 4 is A intersection B is equal to A. So case 2, case 1, I will start from here and I will show this, and I will start from here, I will show this. So let A contain in B to show A intersection B is equal to A. Now to show two sets are equal, we have to show that left hand side contain in right hand side contain in left hand side, then the two sets are equal. Now this is already true, because intersection will always like this. With the help of the Venn diagram, I will explain. This is A, this is B, and we know that this is A intersection B. Now this intersection is there in A as well as in B. So intersection will always be there in the respective sets, whatever they are. So A intersection B is contained in A. So this is already true. We know that this is. Now I have to show that A contain in A intersection B. Now what we will do, I will let x belongs to this, and I will show that x belongs to this as well. So how? Let x belongs to A. Now this implies x belongs to B also. So x belongs to A and x belongs to B. Why x belongs to B? Because A is contained in B. So if x is belonging to A, x will definitely belong to B as well. So if x is belonging to A and x is belonging to B, it means it belongs to their intersection as well. So x belongs to A intersection B. So it means A contain in A intersection B. So from 1 and 2, I can say that A intersection B is equal to A. Now case 2 mein we have to start with the reverse part. A intersection B is equal to A to show A contain in B. Now let x belong. Now if I have to show that A contain in B, I will start x belongs to A and I will show that x belongs to B as well. So let x belongs to A. If x belongs to A, this implies x belongs to A intersection B. Why? Because A is equal to A intersection B. So in place of A, I have written A intersection B. So if x is belonging to A intersection B, it means x belongs to B as well, because A intersection B is this part. So whatever there in this part belonging to A as well as to B. So started from A, reached to B. So it means A contain in B. So it is done, all the 3 parts. So we have proved that 1 is equivalent to 2 is equivalent to 3 is equivalent to 4. It means all the 4 statements are equal to each other.